Human history has been shaped by a few extraordinary moments. Moments when a new idea or a new invention changed the direction of civilization. The discovery of fire, the invention of the wheel, the printing press, electricity, and in modern times, the internet. Each of these innovations transformed the way humans live, communicate, and understand the world. But today, humanity may be standing at the edge of another transformation, one that could become even more significant. A technology that is not just a tool created by humans, but something that could begin to think, to learn, to reason, and perhaps one day to solve problems in ways that surpass human ability. This idea is known as artificial general intelligence, or simply AGI. AGI refers to a type of artificial intelligence capable of general reasoning. Unlike today's AI systems, which are designed to perform specific tasks, AGI would be able to understand and solve a wide variety of problems. In many ways, much like a human mind, the artificial intelligence we interact with today is already remarkable. Systems can translate languages, recognize images, write essays, compose music, and assist with research. But despite these impressive capabilities, today's AI still operates within narrow boundaries. Each system is trained for a specific purpose. A chess program can defeat world champions, but it cannot write poetry. A language model can produce human-like text, but it cannot independently conduct scientific research. AGI would be fundamentally different. An AGI system might be capable of performing many intellectual tasks at once. It could analyze complex scientific problems, design new technologies, discover medical treatments, or help solve global challenges such as climate change. Because of these possibilities, AGI has become one of the most important ideas in modern technology. At the same time, it has also become one of the most debated because the question is not only technological, it is philosophical, economic, and even existential. If machines one day achieve intelligence comparable to humans, what will that mean for our civilization? What role will humans play in such a world? And how should such powerful technology be developed responsibly? To explore these questions, we can look at the perspectives of three influential figures in artificial intelligence, people who are not only discussing the future of AI, but actively building it. The first is the CEO of OpenAI, Sam Altman. The second is the founder and CEO of DeepMind, Demis Hassabis. And the third is one of the pioneers of modern neural networks, Geoffrey Hinton. By exploring their ideas and research, we may gain a deeper understanding of what AGI could become and what it might mean for the future of humanity. Let's begin with a fundamental question. Where did the idea of AGI actually begin? The concept of intelligent machines is not new. For decades, scientists and philosophers have wondered whether machines could ever truly think. One of the earliest thinkers to explore this question was the British mathematician and computer scientist Alan Turing. In 1950, Turing published a groundbreaking paper titled Computing Machinery and Intelligence. In that paper, he asked a simple but profound question: can machines think? To explore this idea, Turing proposed what later became known as the Turing Test. The concept was straightforward. If a machine could communicate with a human in such a convincing way that the human could not tell whether they were speaking to another person or to a machine, then perhaps that machine could be considered intelligent. For many years, this idea remained largely theoretical. Computers were simply not powerful enough. But over time, computing technology improved. Processing power increased, data became more abundant, and machine learning algorithms became more sophisticated. Gradually, machines began performing tasks that once seemed impossible. Recognizing speech, understanding images, playing complex strategy games, generating realistic text. Despite these advances, true general intelligence has not yet been achieved. Human intelligence remains extraordinarily complex. Humans do not simply process information. We learn from experience. We adapt to new situations. We understand context. We imagine possibilities. And we create entirely new ideas. Replicating all of these abilities in a machine remains one of the greatest challenges in science. Yet many researchers believe that progress toward AGI is accelerating. And among the voices discussing this future, one name frequently appears: the CEO of OpenAI, Sam Altman. When discussions about the future of artificial intelligence arise, one name appears again and again: Sam Altman. As the CEO of OpenAI, he leads one of the most influential organizations in modern AI research. Over the past few years, OpenAI has introduced technologies that have changed how people interact with machines. Systems capable of writing essays, answering complex questions, assisting programmers, helping researchers, and even generating creative content. For millions of people around the world, these systems represent their first direct interaction with advanced artificial intelligence. But for Sam Altman, these tools are not the final destination. They are only the beginning. According to Altman, the ultimate goal is something far more ambitious: artificial general intelligence, a form of intelligence that can understand and solve a wide variety of problems, much like the human mind. Altman often describes AGI as a system capable of learning new tasks without needing to be retrained from scratch. Imagine an intelligence that could move seamlessly from one domain to another, a system that could assist doctors in discovering medical treatments, then analyze climate data to improve environmental policy, and later help engineers design entirely new forms of technology. This is the promise of AGI, not just faster computation, but adaptable intelligence. And if such systems become reality, their impact could be extraordinary. Altman has suggested that AGI could lead to a dramatic increase in global productivity. History shows that technological breakthroughs often lead to economic expansion. The Industrial Revolution increased manufacturing output. The Internet transformed communication and information. But AGI could represent something even more profound. Instead of automating only physical labor, it could automate intellectual labor. Tasks that once required years of education and training could potentially be assisted by intelligent systems. Scientific research might accelerate, medical discoveries might happen faster. Complex global challenges could be analyzed at unprecedented scale. But alongside this optimism, Altman also acknowledges the responsibility that comes with building such powerful systems. Because AGI is not just another product, it is a technology that could reshape economies, governments, and entire societies. For that reason, OpenAI often emphasizes the importance of alignment. Alignment refers to the idea that advanced AI systems must operate in ways that remain consistent with human values. In other words, if we create powerful intelligence, we must ensure that it behaves in ways that benefit humanity. Altman has repeatedly emphasized that AGI should not be controlled by a small number of powerful actors. Instead, its benefits should ideally extend across society. OpenAI has even stated a long-term mission to ensure that AGI benefits all of humanity. But one question continues to dominate the conversation. When could AGI actually arrive? Predictions vary widely. Some researchers believe it could take many decades. Others believe progress could happen far sooner. Altman himself has suggested that AI progress has been accelerating faster than many experts expected. Advances in computing power, massive training data sets, and improvements in machine learning algorithms. Together, these factors have pushed AI capabilities forward at remarkable speed. Yet even with these advances, AGI remains an unsolved scientific challenge. Human intelligence is deeply complex. It combines reasoning, memory, creativity, and emotional understanding. Replicating all of these elements in machines will require breakthroughs we may not yet fully understand. For this reason, many scientists approach AGI with cautious optimism. They believe it may eventually be achieved, but they also recognize that the path toward it will involve many unanswered questions. And this brings us to another important perspective. A scientist who approaches the question of AGI not only from the standpoint of computer science, but also from neuroscience. A researcher who believes understanding the human brain may hold the key to building general intelligence. His name is Demis Hassabis. If Sam Altman represents the technological ambition behind AGI, then Demis Hassabis represents its scientific pursuit. Hassabis is the founder and CEO of DeepMind, a research organization that focuses on solving intelligence itself. Before entering the field of artificial intelligence, Hassabis studied neuroscience. He was fascinated by a fundamental question: how does the human brain create intelligence? For Hassabis, artificial intelligence is not only about software engineering, it is also about understanding the principles of learning and cognition. His belief is simple but profound. If scientists can understand how the brain learns, adapts, and reasons, then similar principles could potentially be used to build general intelligence in machines. DeepMind was created with exactly this vision: to combine neuroscience, machine learning, and computational power in order to explore the nature of intelligence itself. Over the years, DeepMind has produced several breakthroughs that have captured global attention. One of the most famous examples is AlphaGo. Go is an ancient board game that originated in China more than 2,000 years ago. Unlike chess, Go contains an enormous number of possible board configurations. So many, in fact, that traditional computer search techniques were considered insufficient. For decades, experts believed that defeating the world's best Go players would require a level of intuition that machines simply could not achieve. But in 2016, that assumption changed. DeepMind's AlphaGo system faced Lee Sedol, one of the greatest Go players in history, and in a historic match, AlphaGo won. This moment became a milestone in the development of artificial intelligence because it demonstrated that machines could learn complex strategies through experience. Rather than relying purely on pre-programmed rules, AlphaGo used a combination of neural networks and reinforcement learning. It learned by playing millions of games against itself, gradually improving its strategy, move by move, game by game. The victory against Lee Sedol was not just about a game. It represented a new way of building intelligent systems that could learn patterns and strategies through experience. But Hassabis never described AlphaGo as AGI. Instead, he described it as a step along a much longer journey. Because solving a single problem, no matter how complex, is very different from building a general intelligence. The real world is messy. Information is incomplete. Situations are constantly changing. Humans rely on intuition, memory, and creativity to navigate this complexity. Building machines that can operate with similar flexibility remains an enormous challenge. Yet DeepMind's research has continued to move forward. Another major breakthrough came with a system called AlphaFold. AlphaFold addresses one of the most difficult problems in biology: understanding how proteins fold into three-dimensional shapes. Proteins are fundamental building blocks of life. Their shapes determine how they function inside living cells. For decades, predicting these shapes accurately was one of biology's greatest challenges. AlphaFold changed that. Using AI, the system was able to predict protein structures with remarkable accuracy. This achievement opened new possibilities for medical research and drug discovery. It demonstrated that artificial intelligence could accelerate scientific discovery. And this is one of the reasons Hassabis remains optimistic about the future of AI. He believes that advanced AI systems could help humanity solve some of its most complex challenges: climate science, medicine, energy, and fundamental research. But Hassabis also acknowledges an important reality. AGI is still an unsolved scientific problem. While progress has been impressive, true general intelligence requires capabilities we do not yet fully understand. Machines must be able to reason across different domains, transfer knowledge from one task to another, and understand the world in a flexible, adaptive way. Achieving these abilities will require new ideas, new algorithms, and possibly entirely new approaches to machine intelligence. For Hassabis, the path toward AGI is both exciting and uncertain. It may arrive within decades, or it may take longer than many expect. But one thing is clear: the research community is now closer than ever to exploring this possibility. Yet as the power of AI grows, another voice has emerged in the conversation, a voice both deeply knowledgeable and increasingly cautious, a scientist whose work helped create modern artificial intelligence, yet who now warns that its future must be approached carefully. His name is Geoffrey Hinton. Among the pioneers of modern artificial intelligence, few names carry as much influence as Geoffrey Hinton. For decades, Hinton worked on a concept that many researchers once considered impractical: neural networks. Inspired by the structure of the human brain, neural networks attempt to simulate how biological neurons process information. For many years, this idea struggled to gain attention. Computers were too slow, data was limited, and the technology required to train large neural networks simply did not exist. But Hinton believed the concept had enormous potential. He continued his research for decades, and eventually the world caught up. Advances in computing power and large data sets made it possible to train deep neural networks. The result was the revolution now known as deep learning. Today, deep learning powers many of the AI systems we interact with every day: image recognition, speech understanding, language models, autonomous systems. Much of this progress can be traced back to the foundational ideas that Hinton helped develop. Because of this influence, he is often referred to as the godfather of AI. Yet in recent years, Hinton has also become one of the most prominent voices urging caution. He has openly expressed concern about the rapid pace of AI development, not because he believes AI should stop advancing, but because he believes its power must be understood carefully. Hinton has suggested that artificial intelligence could eventually surpass human intelligence in certain areas. This possibility has led researchers to discuss a concept known as superintelligence. Superintelligence refers to a form of intelligence that exceeds human capabilities in many domains. A system that could process information far faster than any human mind, analyze enormous data sets instantly, and potentially improve its own abilities over time. Such a system could transform science, medicine, and engineering. But it also raises difficult questions. If machines become more intelligent than humans, who controls them? How do we ensure their goals remain aligned with human values? And what happens if highly capable AI systems behave in unexpected ways? These concerns have given rise to a growing field known as AI safety research. The goal of AI safety is not to prevent technological progress. Rather, it is to ensure that powerful AI systems remain beneficial to humanity. Researchers in this field study how advanced AI systems make decisions, how they interpret human instructions, and how their behavior can be aligned with human intentions. Hinton believes these questions deserve serious attention, because for the first time in history, humans may be creating a form of intelligence that could rival their own. This possibility does not mean disaster is inevitable, but it does mean that society must approach this technology thoughtfully, with careful planning, and with a deep understanding of both its benefits and its risks. When we step back and consider the perspectives of Sam Altman, Demis Hassabis, and Geoffrey Hinton, a fascinating picture begins to emerge. Altman represents the technological ambition to build AGI. Hassabis represents the scientific exploration of intelligence itself, and Hinton reminds us that such powerful technology must be approached responsibly. Together, their perspectives reveal both excitement and caution. AGI remains one of the most ambitious goals in the history of technology. If achieved, it could transform how humanity approaches science, medicine, economics, and global problem solving. It could accelerate discovery, expand knowledge, and perhaps help solve challenges that once seemed impossible. Yet the development of AGI also raises profound questions. Questions about responsibility, control, and the role of humans in a world where machines may possess extraordinary intelligence. The truth is, no one knows exactly when AGI will arrive. Some researchers believe it could appear within decades. Others believe the path will be much longer. But one thing is clear: artificial intelligence is already reshaping our world, and the journey toward AGI has begun. The future of this technology will not be determined by machines alone. It will be shaped by human choices, by researchers, engineers, policymakers, and by society as a whole. Because in the end, technology does not decide the future. Humanity does.